Okay. That is done. So all of you take the settings of practical application of engineering thermodynamic systems. Okay. So after that, so hope you are able to see this figure. Okay. Can you say what this figure represents? Javel. Javel, are you there?
Hello, yes, sir.
So what this figure which you
Hello.
are looking into represents?
Nuclear power plant, sir.
Nuclear power plant. Okay. That's great, man. So this is one of the example of thermodynamic systems. Okay. So not exactly it is a nuclear power plant. It is a steam-based power plant where you burn the coal. From the heat produced by burning the coal will be used to convert water into high-pressure steam. That particular stream would be passed into a turbine where it rotates at a high speed, generating your electric power. So this is how the steam power plant works. Okay, so this is one of the examples of the thermodynamic systems. Where are the thermodynamic systems are going to be applied in the various engineering problems? So you can take this figure if you want, or else you can just leave it. It is not mandate that you have to take it. Okay, so you can just take the examples that nuclear power plant, some of the practical under this heading, some of the practical application of engineering thermodynamic systems. You can just take nuclear power plants, thermal power plants, okay, and you can even plot the rough sketch of this, which indicates the thermal power plant. A flow diagram is enough, I guess. There would be a pump, boiler, condenser, and a turbine. Okay, in the boiler, you will be supplying the heat into the system. So heat will be provided into the system. So through that heat, what happens, whatever the water is getting in will be converted into steam at the outlet, which has a tremendous amount of pressure in it. So that steam is made to impinge on the turbine, by which the turbine rotates, generating the shaft power output. That particular shaft would be coupled to a generator, which is coupled like this generator, where the power is being generated. Okay, so once the steam does its work, again it regains to its original pressure, and that particular steam would be condensed back to water using a condenser. Okay, this water is again pumped to the back to the process. So this is how a steam power plant works in a very first stage I have explained you. Okay, you can just take the flow diagram. Okay, done. You can just take it roughly, man. Don't use scale and pencil for that. Just take roughly. That's enough. Okay. The second example being, how many of you have seen this?
It is shown by Chanakya sir of our department once while explaining this design DME chapter.
Okay. While explaining the design chapter, she showed this particular figure to you.
Yes, yes,
Okay.
yes, sir. Yes.
That's great. So, what does it show upon? What is going on in this figure?
The energy conversion, sir,
Energy conversion.
like
Area
low pressure
taken
to high pressure conversion,
Okay.
increasing its speed, velocity.
Hmm.
and
Okay, Karthik.
extracting the energy from it, sir.
So extracting the energy. It's some source of energy conversion, and
Yes,
even it
yes.
has the extraction base. Okay, fine. So any other answers? So basically, so this particular thing is nothing but your gas turbine. Okay, got the point. So what happens in a gas turbine is you will be inputting a gas into the system, okay, which has a cold section where the temperature of the gas is not so hot, and it has a series of the turbines. See, this is the first stage, second, third, fourth, fifth, sixth, seventh. Hope you are able to guess that. So these are the series of the turbines one by one, where the gas is getting compressed stage by stage. So the pressure of the gas increases a bit here, increases a bit here, increases, and it reaches to the maximum state while it reaches to this particular point here. Okay, so the compression is being carried out in a multi-stage. Okay, after compression, what happens? The fuel is being fed. Okay, the fuel is being fed here like this. Okay, so typical fuels are there which are used in the aircraft engine. Hope my drawing is not so good, but let me try it. So if this is an aeroplane, it has a wings, correct, like this. Yeah, so below the wings there will be two engines. Hope you see that. Okay, these are the engines of the aircraft. So this particular engine is this one. Got that?
Yes, sir.
Yes, sir.
Yes. So you'll be adding the fuel here, by which the heat energy is going to be increased. Here the pressure energy is being increased. Here the temperature has been increased. Now at this point, it has a tremendous amount of power to run this particular turbine here. Okay. So this turbine rotates at very high speed like an aeroplane. So this is one amount of the gas turbine. Okay. So gas turbines are used in the aircraft's engine. And this particular thing operates on a cycle known as a Brayton cycle. Okay, the Brayton cycle is also known as the Joule cycle. We'll see all this. So you can just take the second practical application of the thermodynamic system being the gas turbines. Okay, in the gas turbines, again, there are open type, closed type, all. We'll see that once you are getting into that particular chapter. As of now, we can just roughly take this particular diagram. So the practical application of the gas turbine is being represented in form of a flow diagram here. If you take this, that is more than enough. Okay, so take this very roughly just to understand what is gas turbine. So you can observe the compressor is a dead opposite to a turbine. Okay, in the turbine the pressure reduces, but in the compressor the pressure increases. The compressor is used to increase your pressure, whereas the turbine is used to decrease the pressure. Not really to decrease the pressure, it converts the pressure energy which is at this particular point at the inlet to a shaft energy emerging outlet like this. Okay, so all those pressure energy is being converted into the shaft energy so that the pressure gradually decreases. Shall we move on for then another example of the thermodynamic
Yes,
system?
sir.
Okay.
Yes.
So hope everyone has seen this, correct? So can anyone say what is this?
An internal combustion engine.
Yes, exactly. It is an internal combustion engine. where your heat energy is being converted to the pressure on the piston. So that particular piston reciprocates. The reciprocating motion of the piston is being converted into the rotation motion using a crankcase. Ultimately, what you are doing, you are converting the heat energy, which was in the form of a chemical energy, into a shaft output. So that particular shaft output can be coupled to any of the, if it is connected to a wheels, then it becomes a vehicle. If it is connected to some other thing, if it is connected to a pump, it becomes a pump. Okay. If it is connected to a compressor, it acts as a compressor. Okay, all those things are there. So generally what happens in an engine, the heat energy is being converted into the shaft power output. So these are the PV diagrams. You shall see what is a PV diagram and all, which governs the operation of the IC engine. So do not take it. So you can just write there IC engines. You can just take the rough diagram. Okay, not a 3D model like this. You can just eventually write like this. That is more than enough. If you take this particular thing, that's enough. Okay. If you take this particular thing, that's enough. Just a representation of an IC engine. Okay. See, I suggest you, it might be any subject, not necessarily be the thermal engineering subject. A short diagrams at your page end, if you write a title and a description below it, at the corner, if you draw some of the diagram which just symbolically represents what you are trying to explain in your answer, will definitely add a more weightage to your answer. Man. Okay, try practicing that. It's a good habit. Okay, shall we move on?
Yes, sir.
So fine. So these are some of the few examples where the thermodynamics is being applied. From your side, apart from these examples, any other engineering applications are there where the thermodynamics is being applied? From your side, any of the answers? I have given three. I have given three. So can you give me another three?
Steam turbine.
Yes.
Steam turbine.
So steam turbine has been covered here, I guess, correct? In the first slot.
Hydel energy turbines.
Yes.
Hydel energy turbines.
Hydel energy turbines. So there is the temperature is coming into picture.
No, sir.
So only the pressure of the water is being taken into account, correct? So
Yes,
nowhere
yes.
the temperature is being related. If temperature is not being related, then definitely it is not our concern.
Okay, okay.
Okay, yes.
Refrigerator.
Exactly, that's great, Suraj. So one of the major applications of the thermodynamic systems is refrigeration. Okay, you can take the fourth point as refrigeration. Okay, any other points, guys?
Air conditioner.
So refrigeration slash AC, I can write air conditioning systems. Any other points where the thermodynamics is being applied?
Geothermal energy extraction.
Geothermal energy extraction. Yes, definitely you are using the temperature from the thermal energy which is into the earth crust. We're extracting it from some of the forms of energy. But the thing is, it does not reach the temperature of the
Hello.
There was a problem with the internet. Okay. Is everything okay enough?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So these were some of the practical applications of your thermodynamic systems. So I need another 2 responses from you. There are multiple fields where the thermodynamic is being applied. So I need another 2 examples from you within this class period. Okay.
Sir, what about melting of ice? Hello?
So there was a problem with the college Wi-Fi now. So I've just connected mobile network as of now. So is everything clear? Audio and the presentation?
It's clear, sir. Yes,
Okay,
sir.
fine. Thank God for that. Sure. What I was explaining you, what is exactly the thermodynamic system is? So thermodynamic system is nothing but it is one thing where you are concentrating to do a thermodynamic study. Suppose if it is a pressure cooker, for an example of a basic sense. So this is a pressure cooker. Okay. So you are heating up with a flame. So for me, my thermodynamic system could be the system within the pressure cooker. So this entire thing is my thermodynamic system. Okay. So, apart from the system, it might be anything. So, apart from the system, it might be anything like, see, this is your system, this whole thing is your system. Apart from your system, the entire other thing, all the other thing would be your universe. Okay. So that is the thing. So the system and the universe is being separated by a boundary known as a system boundary. So I can say this particular thing to be your system boundary. It's just the basic terms where you must understand. Just a basic terms: introduction of a system, a boundary, system boundary, and your surroundings. So if you take a turbine for an example, like this. So this is your turbine, okay, where you are inputting the gas and you are exporting the gas with the shaft power output. Okay. So for me, the system is this particular thing which I'm marking. Okay. And apart from the system, all the other things are my surroundings. The whole thing is your surroundings. Okay. Now, the system and the surroundings is being separated by a boundary known as a system boundary. Okay. And there is one more thing, man. The surroundings, this is this. Okay. And the system, which is this, togetherly they are called as universe. The both system as well as the surroundings togetherly they are called as universe. Not high-end science in that, just understanding what is a system boundary, and what is a universe is more than sufficient for you. Okay. So you can take the notes for this. Just take the heading thermodynamic system. Okay. And you can take the figure and all the description given. Okay. So the thermodynamic system is defined as a quantity of matter in the prescribed region of space upon which the attention is concentrated in the analysis of the problem. So in the turbine, exactly the turbine part is considered as system. In the pressure cooker, the inside substance, the whole thing is considered a system, where you are exactly being studying on the thermodynamic aspects of it. Okay. Everything external to the system is surroundings, as I told you. The system is separated from the surroundings by a system boundary. Okay. So boundary, what is a system boundary? It is the actual or hypothetical envelope. Hypothetical in the sense it might be there or it might not be there. You must assume it. So it is an actual, it might be there, or hypothetical, you can assume it, envelope. And closing the system is known as the system boundary of a system. The system and its surroundings together comprises the universe. You can take all the description given and this figure, small figure. Okay. Tell me once you have done. So these definitions are often asked in exams. One more thing I wanted to just discuss. So I went to a library and collected few of your question papers previously for the thermal engineering subject. I have got only two men. It would be grateful to you if you have got any of the question papers with you. You can share with me. I've got only two, 2019, I guess, both of them. Then kindly share with me, okay? Saga, is that done? Sagar is Acharya.
Yes, sir.
Shall we move then?
Yes, sir. Just the diagram.
Okay, okay, okay. Good, good.
Yes, sir. We can continue.
Okay. So now we shall try to analyze the different types of system. Okay. So hope you got the concept of system, system boundary, and surroundings. It's just a simple concept to understand the thermodynamics. Okay. Now there is a system here. What are the different things that can get into the system, and what are the different things that can get out of the system? So whatever it is getting in can be taken out, is it? So what are the different things that you can exchange within the system?
Energy and mass.
That's it, nothing other than that. Okay, the first thing is energy and the second thing is mass, is it? So only these two factors can be interchanged within the system and the surroundings. So surroundings can give input to the system as in case of one. Okay, as in case of two, the system can give out energy to the surroundings. Okay, as in case of two. So different types of systems where the energy and the mass interactions being takes place can be classified into three different uh, categories. Okay, so let me explain you in detail about this. So now there is a system here like this. Okay. So in this type of a system, I would say this is system one. System one. Okay. So as you can see, there are three different systems. In these three different systems, I would be specifying how this system behaves. For example, system one can input and output the energy. Okay, system one can input and output the energy. Okay, and even system one can input and output the mass. Okay, the system one can input and output the energy as well as the system one can input and output the mass. Okay. In the second thing, system two cannot input the mass. So what happens in system two? It cannot input the mass, but yet it can input the energy. Got it? The difference between the system one and system two is system one can input both the things, can exchange both the things, energy and mass, whereas the system 2 can exchange only the energy with the surroundings, but it cannot exchange the mass as indicated here. Okay, it cannot exchange the mass. Coming to the system 3, for system 3, it is not possible to exchange energy as well as the mass. So both energy and mass neither can be exchanged in the system 3. Got it? So these are the 3 different systems. Now, I am categorizing it into 3 different systems. I will be naming this as open system, second one is the closed system, and third one is the isolated system. So can you guys say which system represents which type? There are 3 types of systems. One is the open system, second one is the closed system, and the third one is an isolated system. So according to you, I have described all the 3 systems, whether the system 1 is open system, whether the system 2 is open system, whether the system 3 is open system according to you. So which one is an open system? So system 1 is open. Okay, that's great. So system 1, I can just write it here it as the open system. What about system 2? Whether it is an isolated or it is closed?
Closed.
So according to you, system 2 is what?
Closed.
Closed or isolated?
Closed.
Isolated.
Okay. So there is a mix of opinions. So if this system is isolated, for an instance, okay, what could be this system then, where there is no energy and mass transfers? Which is completely isolated with its surroundings. Yes? The meaning of a word isolation in the sense, it is complete isolation. So it cannot interact with the mass, it cannot interact with its energy. So such a system is called as isolated system. Okay, do not get confused. A closed system is something where your mass cannot exchange, but your energy can exchange. So number 2 system, I can name it as closed system. So coming to a conclusion on this, open system is something, okay, where both energy and mass interactions can take place. Okay. Second one is your closed system where the mass interaction is not possible, but the energy interaction is possible in your closed system. The energy can definitely interact. So interact in the sense it can give out to the surroundings or it can take from the surroundings. That particular interaction of energy is possible, but not the mass. If such is the case, then I would be calling it as the closer system. So second one is the closed system. What happens in an isolated system? In an isolated system, both the mass as well as the energy cannot interact. That means there is a perfect isolation with the surroundings. There is no chance of any intervention of a system with its surroundings. So such a system is known as the isolated system. Hope you are clear with this. Okay. Any doubts regarding this?
No, sir.
No, sir.
Okay. So you can take the notes for it. Okay. So think of examples while you are taking notes, man. So when you are taking notes, I have given some of the examples. Think whether that particular example is perfectly suited for that particular category which I have mentioned there. Okay. If any problem with an example, no sir, this particular example is not suitable for this particular system, then you can raise your voice and speak to me. Okay.
Excuse me, sir. Hello?
Yes, Karthik?
Sir, can you please explain that passenger train will stop at a platform? How it is related to open systems?
Okay, definitely I will do that. Okay. Shravan Pujari, what's your USN name?
17MT051.
051. So your name in the attendance list is as Shravan Kumar.
Yes, sir.
Okay. It's Shravan Kumar Pujari, correct?
Shravan Kumar only, sir.
Okay. Niharika Rao.
Yes, sir.
So why were you absent for the last two classes?
Sir, it was placements.
Okay, because of the placement. I told, okay. How do I get that confirmation that you have attended the placements? Because I need a list of students who have attended the placements, right?
Sir, I have the shortlisted mail. If
That's
I
a
can.
different, you can prove for yourself, but I need the list.
Yes. Can I send that to you, sir? Shortlisted
Sure.
mail.
You have to send that to me so that I can mark that per month and present.
Sure, sir. Yes.
Okay, thank you. Let's see. Yes, have you taken it up? Shall we move?
Sir.
So we shall discuss the examples now. So the first one is boiler. So what happens in a boiler? In the boiler, you'll be inputting water and you're taking out the steam and you're inputting the energy, which is the heat energy, is it? So there are both mass as well as energy transfer in and out of a system. So definitely it is an open system. No other confusions in the boiler, correct? So this particular example of passenger with train, passenger entering and coming out of a train while it is in the platform, was asked in your VTU question paper. Okay. So I don't know in what sense they have related this particular example for a thermodynamic subject, but they have asked it. So according to him, the passengers getting in are considered as a masses. So passengers can get in, so masses can get in. Passengers can get out of the platform, so masses can get out. So according to him, this is an open system. I have seen the scheme of evaluation for that particular paper. So this was the thing written there. Okay, so just have an idea. If in case they might ask, so I have just included this particular example of passenger train will stop at the platform. Let's stop at the platform. Okay.
Sir, what about energy in this example?
What about?
Energy, sir. Only masses.
So there is a concept called if there is an exchange of mass, then definitely there would be exchange of energy.
Oh, okay, sir.
Okay, that is how it is. Okay, you can just relate. See, this particular example of passenger in a train is just stupid as it is. Okay, because see, it is first of all not a thermodynamic system. It is a general example. You cannot relate a general example with the thermodynamic study, is that? So that's why, yes, they have given in the video question paper, so you can understand in this way. Definitely, if there is a mass interaction, and it is true in the thermodynamic sense also that if there is a mass interaction, definitely there would be a energy interaction. Okay.
Yes, sir.
Okay. So throttle wall is something which is often you might have come across. So there will be a pipeline which is going on. Okay, and there will be a valve connected like this. Okay. So if you turn on or turn off the valve, the pressure at the output will vary. Okay. So this is nothing but your throttle valve. So definitely here there is a exchange of mass. So when it is an open system, then definitely it is an exchange of mass. If there is an exchange of mass, again there will be exchange of energy. That's how it becomes an open system. Okay. Any other doubts in the examples? Pressure cooker, yes. So once the pressure cooker lid is being turned off, where it's being closed, then that particular example can be considered as your closed system. Again, you must not fall in confusion that, sir, you are adding rice and other stuff into this pressure cooker, so exchanging mass into it. How could it become a closed system? It has to be open system. So don't think in such a way. So you can just analyze the things when the lid is closed. Okay. Second thing is the IC engine during the compression and expansion stroke. Yes, see, this IC engine concept is there where it acts as both open and closed system simultaneously in the different strokes. How I will be explaining now. Okay, so think this is an IC engine. Okay, it has a valves like this, correct? Okay, so hope you know how an IC engine works. Okay, it has 4 strokes in it. The number 1 would be suction, number 2 compression, number 3 power, and number 4 exhaust, is it? So during the suction and the exhaust, what happens? The inlet and the outlet valve will be open. So during the during the suction stroke, what happens? Your fuel and air mixture gets inside the cylinder. That means there is a mass interaction with the cylinder. During that particular stroke, the system acts as the open system. But the same thing during the exhaust stroke also. During the exhaust stroke, what happens? The burned gases will escape out through the exhaust valve. So definitely there is a mass interaction and it becomes an open system during the exhaust stroke. But what happens during the compression and the power stroke? Both the valves are being closed, correct? So during the compression, your piston moves from BDC to TDC, compressing the gas. Okay, so there is energy transfer, and even in the power stroke also, the piston moves from TDC to BDC. Okay, the piston moves from TDC to BDC, and you will be supplying the heat input into the system. So definitely there is no mass interaction, and there is only the energy transfer into the system, especially in power and compression strokes. So during the power and compression strokes, the IC engine can be treated as a closed system. That is how it is. Okay. And same example goes with the thermal flask also. Thermal flask is a totally insulated body. You can say that you are inputting hot water initially. Okay, fine, you are inputting hot water initially. Once you close the thermal flask, then that particular system can be regarded as your isolated system, since there is no mass transfer in and out of a system and there is no energy transfer in and out of a system. Okay. So if you want, you can take this diagrams which are taken from this I have drawn by my own, but these diagrams are from the textbook. So if you want, you can just take a sketch of it. Any other doubts regarding opens, closed, and isolated systems?
No, sir.
Okay, sure. Shall we move on?
Yes, sir.
Okay. Okay. So next concept is the concept of adiabatic system. So what exactly it is? So you have defined the open system, you have get to know the closed system, you have understood the isolated system. But what is this adiabatic system? Suppose this is a system. Okay. In this particular system, there is no energy in and there is no energy out. So there is no energy transfer in and out of a system, and even the mass cannot enter the system nor the mass cannot come out of the system. So definitely there is no energy as well as the mass transfer into the system. So as of now, which system it is? With this description of this system, isolated, correct? So as of now, it is isolated system. So if this particular system, which is isolated in nature, exchanges work with the surroundings. Now what it is doing, it is exchanging the work with the surroundings. Okay, there is a new concept of work here. So if this particular isolated system exchanges work with the surroundings, then it is termed as adiabatic system. Okay, what is an adiabatic system? Adiabatic system is nothing but an isolated system where there is no energy and mass transfers absolutely, but it has a capacity to transfer or interact through the work with its surroundings. Then such a system is known as the adiabatic system. Got the definition of adiabatic?
Yes, sir.
Okay, so kindly take the definitions of it. So adiabatic system is one which is thermally insulated from its surroundings. It, however, exchanges work with its surroundings. If it does not, it becomes an isolated system. That is what I have just explained to you. So just take the heading adiabatic system and these things.
One doubt, sir.
Yes, Karthik.
Sir, without the exchange of energy, how can we say that work is done?
You will be coming, this particular point will be conveyed to you while we are discussing the work. Since, yes, you are 100% correct, without the energy interaction, there is absolutely not at all possible to transfer your work or get the work done by the system. But the thing is, such systems are idealistic in nature. They would never expect, and we all expect all the systems to be in adiabatic in nature, which exchanges nothing but gives out work.
Okay.
Which is not possible. Done writing. So if it is done, we shall end up the class.
Yes, sir.
Okay. So I want the reviews from you. Are you understanding the subject and the way it is delivered to you? It is accessible to you. Any problems in understanding the things?
No, sir.
No, sir.
No, sir, no problem. It's
No,
perfectly
sir.
fine.
No problem.
Okay. So is the pace good? So we'll be continuing with the same pace, in the sense, in the same speed. Okay. Because your
Yes, sir.
syllabus is huge, so we need to little bit increase our pace. That is eventually required. Okay. From the next class, we'll be just increasing our pace. Okay. And I want your support. Take down notes very fast and give me more time to explain you. Okay.
Sure, sir.
Okay. So shall we end up for today?
Yes, sir.
Yes,
So
sir.
your attendance has been marked already. Okay. Have a nice day.
Thank you,
Take
sir.
care.
Thank you, sir.
Excuse me, sir.
Yes.
Thank you, sir.
Thank you, sir.
So may I have your mail ID?
Yes, it is. I will just post it in the chat box.
Okay, sir.
So here it is.